All right, if I can get your attention up front, we're going to go ahead and get started. So today we are talking all about scatter plots, how to draw them both by hand and with a calculator, how to describe the properties of a scatter plot, how to quantify those properties. And we're going to talk more about that tomorrow, and we'll do an activity to get some practice with it. Yeah. So we just talked about labeling our axes. We know we're going to put the explanatory on the x-axis, and we are going to put the response on the y-axis. Which generally means when we start this process, I should know which my explanatory and which my response variables, yeah? Identify those first. That kind of goes without saying. Assuming I have already identified my explanatory and response variables, I have a blank space on my paper. I want to construct a scatter plot. What's the first thing I should draw? Draw some axes. Very good. We're going to draw and label our axes. For our bell ringer, we draw an x and y axis. We label it weight in tons and miles per gallon. Right? Okay, next one. Now that I've got axes on the paper, in order to plot points and have those points be meaningful, what else do I have to do? Scale it. Very good, Katie. Scale the axes. Reminders that your scale should be uniform. I don't know why that became Scully. Uniform scale. Hash marks should be evenly spaced. We're counting by the same chunk of numbers each time. Counting by 2s, counting by 5s, counting by 10s. Whatever we're counting by, it's the same on the whole axis. The upside is once you've got your grid drawn, just apply your points. Right, we're back to middle school math. Over and up, make a dot. Over and up, make a dot. Over and up, make a dot. We're going to do this together for practice because it's good for us. So you will notice in the example, we have some data from you guys. I randomly selected 12 people from a spreadsheet from the data you guys gave me during the first week. So this is height versus maximum time holding your breath for 12 random AP Stats students this year. And we want to see if there is a relationship between the height in inches and the max time holding breath for AP Stats students. So we're going to make a scatter plot for them. So first thing, draw our axes. Yay. And I hear some people grabbing rulers, and that makes my math heart very happy. How did I know which variable went where? Yes, Katie. And the AP board is going to follow that pattern consistently. If they give it to you in rows, first row is X, second row is Y. They give it to you in columns, first column is X, second column is Y. They will be consistent with that. Even if they don't label it X and Y, always will be in that order. So I can tell from the structure of the table that height is my explanatory variable. and max time holding my breath is my response variable. Good. Next step is generally the hard part of doing these freehand, which is figuring out how to scale your axes. And I start by looking for the maxes and mins on both axes. So for height, the shortest person in this sample was 61, and the tallest was 71. And I've done this twice today, so I happen to know I can start 2 out with 61, and then every other box is 1. 62, 63, 64, 5, 6, 7, 8, 9, 70, 71. On the y-axis, same process. Smallest and largest. Smallest is 17 seconds. Largest is 100 seconds. That's a little bit of a tighter squeeze. I happen to know that if 15 is here at that intersection and each box is 5, 100 will be the last line in the graph. So this second hash mark here is 20. And then every other box is 10. And 17 is going to be between the bottom and 20. So it'll just barely fit in there as a little bit less than 20. Yes. That's an excellent question. When we are drawing scatter plots, your intersection between x and y does not have to be at the origin 0, 0. Because we are not worried about relative heights between bars like we were for bar charts and histograms. So we're not skewing anything by compressing that axis and shifting the intersection. That was a good question. Yeah. I'm glad you brought that up. So the AP board will not make any indication other than the axis labeling that that intersection is not at 0, 0. You would just be expected from reading the graph to intuit that it's obviously not crossing at 0 if this is 20 and this is 61. As scientists and mathematicians, you probably learned that it's appropriate to include a little squiggle down there to indicate that you're not starting at 0. You're eliminating some of the axis. Yeah? And that is considered good form. The AP board won't do that. I'm not going to dock you up points if you forget to do that because the AP board won't. Your book is going to do something slightly different. Instead of doing this squiggle, your book is going to use 2 hash marks to show that compression or that gap in the axes. Either of those is appropriate. If you forget either of them, I'm not going to dock you. It's fine. As long as you label your axes appropriately, we'll be able to figure out what you meant. Last step. Let's plot some points. I'm going to give you about 2 minutes. This shouldn't take long. We know how to plot ordered pairs. First ordered pair, 68, 100. I'm going to let you plot the rest. Check my math, make sure I got what you got. 64 and 30, 62 and 25, 65 and 69. 71 and 17, 68, 167 and 30, 62 and 29, 67 and a half, and 60. Hello.
By any chance? This one
Yes.
and then this one.
Yes.
Sorry, I think it's and that one.
Yes.
Yes, sorry.
I have all of them. Jaden. Now I have to remember where he was. I got 60, 75 and a half, 60, 62, and 60, 61 and 60, 65 and 30. Okay, I think I got all of them. You double check. I see some nodding and some yeses. That's good. That is the extent of drawing a scatter plot by hand. Draw and label the axes, scale your axes, slap some points in there. Yeah. Skill we learned to do that in Math 1. You've practiced it in other science classes. Yeah. Good. So the downside, that's a little time consuming. Not quite as bad as histograms, but worse than bar charts for sure. And we're pressed for time. So another way to do this is with technology. So if you don't already have your calculator out, you should get your calculator out because that's the next thing we're going to talk about, which is how to do this on your TI-84. Yeah. If the question to the class, if I want to make a graph of some data on my calculator, what's probably the first step? Not the graph button. Stat. Yeah, there you go. Get the data in the list, right? Get the data in the calculator. So stat. And then enter will take you to the edit menu. And then you're going to put your X values into list 1. And you're going to put your Y values into list 2. Or explanatory in list 1, response in list 2. I'm going to give you a minute to do that for the data on the first page. Height into list 1, max breathing time into list 2. Oh. Okay. So anytime something funny is going on in this screen, if you go stat and then go down to setup editor and run that command, go back to your list now. Yep. That'll fix almost anything that's wrong with your list. Some of us are fast typers, some of us are slow typers. If you know you're on the slow typer end, you need to start practicing typing on your calculator. Speed is a factor when it comes to AP test day. List is in. List is in. This table's fast. This table's slow, and I see 3 calculators and 4 humans. Frowny face. Cammy, where's your calculator? Sad face. Tomorrow we're going to do an activity. Make sure you have it tomorrow. Jaden, where's your calculator? Bree, where's your calculator? You guys are killing me. All right, I'm going to assume most of you have data in your list. If you don't, step on the gas. Next step, I want it to graph, but I'm not graphing a function. I'm graphing statistics data. I don't want to press y equals. I want to press second and then y equals. And when you do that, it should take you to a menu titled Stat Plot. Second, and then y equals. When you're in the Stat Plot menu, you're going to press Enter to select the first stat plot. And that's going to take you to a menu. The first choice in that menu is on or off. You want to turn your graph on. Otherwise, it won't plot. After that, you want to tell it what type of graph you want. There are going to be pictures. You should choose the picture that looks like a scatter plot. It should be the first one. And then you need to tell it where your data is. So X is in list 1 and Y is in list 2. After you have done that, there are some aesthetic choices. What do you want the calculator to use as dots? What color do you want those dots to be? As your stats teacher, I do not care about those aesthetic choices. Do whatever makes you happy. That is a great question, Jennifer. How do we graph it now that it's in there? And the answer is do not press the graph button. If you press the graph button, it's going to think it's plotting a function and it's not going to be happy. You want to press the zoom button. It is in the middle of the buttons underneath your screen. And from zoom, you are going to choose option 9, which should say zoom stat, which tells the calculator it is making a statistics plot and not a graph of a function. You should do that now, and you should see the graph we made together on page 1. If you do not, raise your hand so I can come fix it for you. So that probably means that you've got stuff in your y equals menu. Try it again. Yes, Yari.
Okay, my list are all good, right?
Good.
So,
Second, y equals.
y equals,
Enter. Enter again. And then we're going to go down and notice scatter plot is selected. L1, L2. Everything's where it should be. So zoom. And then zoom stat. Option 9. And then enter. Yeah. Yeah.
Where do I go from here?
Zoom.
Oh.
And then all the way down to zoom stat. Okay, so it says dimension size. So let's go enter. And first we're going to check your list. Make sure it's the same size. And it is not. You missed a data value. So that is probably it. For calculator? Or yes, I do. Well, if he got them backwards, he just needs to reverse the labels in the stat plot. X is in list 2, Y is in list 1.
You didn't have help.
You're welcome.
Figure something out because Ishana, hers wasn't working, so we realized that both lists have to be equal in
Yep.
value.
Or it spits back a dimension mismatch. Yep. Good. Yeah.
Is there ever gonna be like when you just give us like the graph and we have to like figure out questions?
On the multiple choice section, yeah.
How will we know if there's like 2 points?
So often when that happens in a graph, each of these would be labeled point A, point B, point C, and you would see 2 labels on that point. Yep. Excuse me, Amy. Ooh. So go to, and then do zoom stat, and it's going to say, so go down to go to and press enter. Notice that you have stuff in your function. You've got all kinds of stuff in your function, yeah. So now let's try it.
Oh, you're an angel. Thank you.
All right, a couple of things if I get your attention back up front. First, we had a really good question about the graph we made together on the front, which is there were 2 data points at 68, 100. This point here had 2 data values at it. The question is, how do we know that's true? So if that happens on the AP test, typically they will label the points with like letters or some code. So like point A, point B, point C. And that point where it's got 2 points on top of each other would then have 2 letters associated with it, A, comma, D, right? Otherwise, you're right, we wouldn't know. So if they're giving that to you in a multiple choice question and they want you to answer questions about it, it should be indicated. Yeah, they should give you some label. Another couple things. First, one of the most common errors is you still have stuff in the y equals menu, in your function menu from like math 3 from last year, right? You got to clear that out because if it's nonsense, it'll cause errors. Second, check your lists. They need to be the same length. Otherwise, you're going to get a dimension mismatch error. Yeah? Third, anytime your calculator gives you an error, if it gives you the option to go to, select go to and not quit, because it will take the cursor to the place where you have a problem. That makes it easier to fix because at least we know where the problem is. Yeah? Good. Okay. Last warning before we move on. If you are using your calculator to construct a scatter plot on the AP exam, do not just copy the unlabeled graph off your calculator. It is fine to use it to help get the shape, right? I can do this and make some dots where I know they kind of are on the graph, yeah? That's fine. But I need to do 2 things. I need to label the axes with variable labels. I need to tell them I am plotting height. I need to tell them I am plotting max time in seconds, right? That's important. And I need to give them a sense of scale. In this case, I know my minimum point was at 61. My maximum was at 71 on the X, just from the table that I plugged in. I know here my minimum was at 17. My max is 100. I don't have to scale it, right? I don't have to have every hash mark. But I need to have some numbers on that axis so they have an idea of scale. Yeah? So don't just copy it and then not label it. You have to label it. If you copy it without labels, you get no credit for doing it. Have to have labels. Good. Okay, questions about making scatter plots? No. Okay, now the fun part, the statistics part. How do we describe them? We encountered that during our bell ringer today. What kind of words do we use to describe? If I'm looking at one variable data, what are the 4 descriptors I have to go through? Shape. Socks. Very good. Socks. Shape, outliers, center spread. That's perfect for single variable data. Less helpful when I am looking for relationships between variables. We need a different set of descriptors for 2 variable data. So that's what we're going to talk about. There are 4 descriptors for 2 variable. They are different than SOCs because we're interested in different things. The first is the direction of the data. Which way does it tilt? If it tilts upward, we would say that there is a positive association between the 2 variables. As one increases, the other increases. If the graph tilts downward, we would say it has a negative association. I can see the first 2 graphs. The first one is a positive association. The second one is a negative association. Notice that those descriptors match the slope of the graph. the average rate of change. Yeah. The last case is I have something that is blob-like, and that indicates that there is no association between the variables. There are two ways this might show up. The first is blob-like. There is another shape that indicates there is no relation, and that is when the graph is horizontal. A horizontal graph tells me that as I increase my x, my y does not change at all. There is no connection between x and y because I'm messing with x and I'm not seeing any fluctuation in y. Yeah. This implies there are fluctuations in both, but those fluctuations are not predictable, meaning they're happening at random and they're probably not influencing each other. So both of these indicate no relation. One of them implies that there's really in reality no connection. For the first two graphs, with a positive association, as x increases, what happens to y? It also increases. Very good. These guys change together. One goes up, one goes down. Or one goes up, the other goes up. One goes down, the other goes down. Same direction. For negative, as x increases, what happens? Y decreases. Very good. These guys change in opposite directions. One goes up, the other goes down, vice versa. So positive changes in the same direction, negative changes are in opposite directions. Very good. So that's the first thing you do. Kind of stand back, blur your eyes, look at the general shape, which way does it tilt? Next is we need to describe the actual shape. There are three categories, just like we had for the first point. Your graph can be linear. Your graph can be nonlinear. Your graph can have no clear pattern. We know what linear looks like. It's a line. Nonlinear is some other type of pattern, usually some curve. Most commonly in statistics, it's going to be exponential or logarithmic or quadratic. Those are the common ones. Yeah. Sometimes square root. We like linear because we know how to do math with it. Yay, we could do statistics and predictions with linear data. We like curvilinear data because sometimes we can tweak the variables and force the graph to behave like it's linear. And then we can do math with it. Yay. If there is no association, we probably stop what we are doing because there's no relationship there, and we move on to another research question. Tweak what we're looking at because there's no relationship here, nothing interesting. Once you've identified the shape as linear or nonlinear, assuming there is a shape, you should indicate how strong that relationship is. The strength of the relationship. When you look at that graph, is it immediately apparent as linear? Or is it kind of blob-like with a weak tilt? Yeah. We typically classify this into one of three categories: weak, moderate, and strong. Strong is very apparent. Weak is kind of blob-like with a slight tilt. Moderate's in between. And then the last is we look for unusual points. Points that don't fit with the rest of the data. They could be incongruous with the pattern or shape that we identified earlier, meaning the rest of my graph is exponential, and I've got like one point way down here that's not with the rest of the exponential data. It could be that it's a data value that has an x value that's incongruous. It's way out to the side. Could be one that has an incongruous y value. It's way up here or way down here relative to the rest. I have a pen somewhere. Yes, Katie. It is, you won't see that word used here. They're making a distinction between the vocabulary that we use for one variable and the vocabulary that we use for two variables. As outlier, we used 1.5 IQR rule, and that was along one axis. Now I have to consider two directions where I could have issues. So unusual points for now. We're going to talk about residuals later. That also ties into that. So we now know there are four things we look for. We describe a graph: direction, shape, strength, and unusual points. We have a graph. On the previous page, I want you to take about 90 seconds in your small group and identify direction, shape, strength, unusual points. Are you sure? Are you sure? Remember that weak is a possibility here. Why are you staring into space?
There was a blue blood on Jaden who just flicked it instead of shielding me.
I'm sorry.
It was scary.
Choose better friends.
Jaden
Shape.
was not my friend.
You chose to sit there.
Jonathan, you need to leave right now.
Yeah.
Who had the lowest grades? Because I heard like 61, 57. That wasn't the lowest. There was no. So you really meant like we had the lowest of the low.
And the highest of the high. Yeah, you had both. And you had all of the low scores. Like all of the ones that were like way down at the bottom, like 3 or 4, all of them were in fourth period. But so was the highest A. So the spread of that data is like fourth period is like this, fifth period's like this. Excuse me. All right, I need a volunteer to share what they thought about those 4 points describing the shape of that graph. And I will call on Katie if no one else volunteers, but I want to hear some other voices today. This table is generally quiet except for Austin, who I called on earlier. Back corner is always quiet. You guys are pretty good. Sort of quiet, almost always quiet, very quiet, but I picked on you today. We have a vote for no association. Can I get a thumbs up if you agree? So that is tempting, and I agree it is vaguely blob-like. However, as a practice statistician, yep, I am very sure, as somebody who's been doing this a long time. Yep. So, if I could bring us back together, that immediate visceral reaction is we disagree, right? People are going to see different things when they look at graphs because those descriptors are, to some extent, subjective. So the question as statisticians is, how do I take that subjective rating and turning it into something that is not subjective? How do I quantify it? And the answer is with a correlation coefficient. It is, and it's a tongue twister. Your book does not refer to it as the correlation coefficient. Your book refers to it as just the correlation. I don't know why it does that. It is the correlation coefficient. Every other statistics book will use the correlation coefficient. And we use the letter R to represent the correlation coefficient. And what I would like to do for the remainder of today is talk about some properties of the correlation coefficient. And then tomorrow we will talk about how to calculate it. Yay. All right. First thing you should know about the correlation coefficient. It is always a number between -1 and +1 inclusive. It's usually a decimal. It is a ratio of things. We're going to, not exactly, but kind of, we're going to look at the formula tomorrow. The sign on your correlation indicates the direction of the linear relationship. And it is important that you notice that keyword linear. We only do correlation and regression on linear graphs. So there is an assumption that this graph looked vaguely linear if I am doing this calculation. If it was clearly exponential, I would not be doing this. Next, you only see ±1 when it is a perfect linear relationship. If it's a perfect linear relationship, what's my graph going to look like? Straight line, yeah. Perfectly straight line. All of the dots are on the same line. Do we expect that we are going to see that in nature very often? No. Nature is more complex than that. That does not happen very often. You should be surprised if you get a correlation coefficient of exactly 1. This is not calculus. This is the real world. Calculus is theory. This is practice. You keep your calculus in your calculus class. We can talk about that after I finish. Last, when we talk about weak, moderate, strong, if it is strong, it should be close to ±1. The typical cutoff is about 0.85 to 0.9. Anything above that is strong. It is weak if it is close to 0, 0.2, 0.1, 0.25, even 0.3. It's kind of weak. Moderate is in between, that 0.3 to 0.8 kind of region in the middle, right around 0.5. So I would encourage you to take a look at the example below that and see if you can match based on sight. We're going to pick up here tomorrow. I'm going to show you how to use your calculator to find R, and then we're going to do an activity where you get to collect data and practice scatter plots and correlation coefficients. Yes, Katie? So, and this is a rough estimate, but if I'm looking at a number line from -1 to 1, typically this region from like -0.3 to 0.3 would be weak. Anything past 0.85 would be strong. And that in-between zone between 0.8 and 0.3 is the moderate. Because remember that the sign just tells me about the tilt. It's a strong negative. If it's close to +1, it's strong positive. Yeah. It's distance from 0. Distance from 0 in either direction. Yeah. Good. Reminders. You have homework from last week. Yeah. There is homework that goes with 3B that's already posted. We're going to finish 3B tomorrow, do an activity. Yay. On the way out the door, I'm going to ask you to give me thumbs up if you're feeling pretty good with today's lesson. Thumbs down if you're totally lost. Thumbs sideways if you're you got it, but not really. You want more practice. So happy face, frowny face, meh. Meh. I feel the meh today. I really do. Austin, would you do me a favor and stop the recording? Thank you. Show me your thumbs, Chris.